What if you could travel through time? Go back and meet your younger self. Visit the dinosaurs. See the future. Is time travel actually possible, or is it just science fiction? Today, we're exploring the science of time travel. From Einstein's theories to real experiments. From wormholes to time dilation. The answer might surprise you. Let's start with the basics. What is time? It seems simple, but time is one of the most mysterious concepts in physics. We experience time as flowing in one direction, from past to future. We remember yesterday, but not tomorrow. We age, we change, and time marches on. But according to physics, time isn't what it seems. Einstein's theory of relativity revolutionized our understanding of time over a century ago. Einstein showed that time is not absolute. It's not the same for everyone everywhere. Time is relative, and it can be stretched, compressed, and even bent. This is called time dilation, and it's been proven in experiments. Time actually moves at different speeds depending on how fast you're moving and how strong gravity is. Here's a mind-blowing fact. If you travel at high speeds, time slows down for you compared to someone standing still. This isn't theory, it's reality. Astronauts on the International Space Station age slightly slower than people on Earth. The difference is tiny, just a few milliseconds, but it's real. In 1971, scientists put atomic clocks on airplanes and flew them around the world. When they landed, the clocks on the planes showed less time had passed than identical clocks on the ground. This proves time dilation is real. The faster you move, the slower time passes for you. So in a sense, astronauts are already time travelers moving into the future. If you could travel at 99% the speed of light for 1 year, when you return to Earth, decades would have passed. You'd have traveled into the future. This type of time travel is possible. It's called time dilation, and it's a consequence of Einstein's special relativity. The problem is we can't travel that fast yet. But there's another way time can be manipulated. Gravity also affects time. The stronger the gravity, the slower time moves. This is called gravitational time dilation. Near a massive object like a black hole, time slows down dramatically compared to far away in space. In the movie Interstellar, they visit a planet near a black hole where 1 hour equals 7 years on Earth. That's actually based on real physics. If you could orbit close to a black hole and then return, you'd have traveled into Earth's future. Your friends and family would have aged decades while you aged hours. So traveling to the future is possible. We know how to do it. You just need to move really fast or hang out near a black hole. But what about traveling to the past? This is where things get complicated. Traveling backward in time is much more difficult, and it might be impossible. Einstein's equations don't forbid backward time travel. In fact, they allow for solutions where time loops back on itself. One theoretical method involves wormholes. A wormhole is a tunnel through spacetime connecting two different points in space and time. If wormholes exist, you could enter one end and emerge at a different time and place. You could potentially travel to the past. But there are huge problems. First, we've never found a wormhole. We don't know if they exist in nature. Second, even if they exist, they'd be incredibly unstable. They'd collapse instantly unless held open by exotic matter with negative energy. We've never observed exotic matter, and it might not exist. So wormholes might be mathematically possible but physically impossible. Another theoretical method is using a rotating black hole. Some solutions to Einstein's equations suggest rotating black holes might contain pathways to the past. But again, this is purely theoretical. And even if it worked, the journey would likely destroy you before you could travel through time. There's also the cosmic string theory. Cosmic strings are hypothetical defects in spacetime left over from the Big Bang. If two cosmic strings pass by each other at high speed, they might create a closed time-like curve, allowing time travel to the past. But cosmic strings are purely theoretical. We've never detected one, and they might not exist at all. Here's the biggest problem with backward time travel. Paradoxes. If you travel to the past, you could change history and create contradictions. The most famous is the grandfather paradox. If you go back in time and prevent your grandparents from meeting, you'd never be born. But if you're never born, you can't go back in time to prevent them from meeting. It's a logical impossibility. So either backward time travel is impossible, or something prevents paradoxes from happening. Some physicists propose the Novikov self-consistency principle. This says that even if you travel to the past, you can't change anything. Events would conspire to prevent you from creating a paradox. You'd always fail to kill your grandfather, no matter how hard you tried. Another solution is the many worlds interpretation. When you travel to the past and change something, you create a new parallel universe. In this new timeline, your grandparents never meet. But in your original timeline, they did. So there's no paradox, just multiple timelines. This sounds like science fiction, but it's a legitimate interpretation of quantum mechanics. We just don't know if it's true. Some scientists believe the laws of physics might simply forbid backward time travel. Stephen Hawking proposed the chronology protection conjecture. This idea suggests that the laws of physics conspire to prevent time machines from ever being built. Nature doesn't allow paradoxes. So far, every proposed method of backward time travel has problems. Either it requires exotic matter we've never seen, or it creates paradoxes, or it's just too unstable. But here's something fascinating. We're constantly receiving information from the past. When you look at the stars, you're seeing them as they were years ago. The light from the sun takes 8 minutes to reach Earth. So you're always seeing the sun as it was 8 minutes in the past. The Andromeda Galaxy is 2.5 million light-years away. When you look at it, you're seeing it as it was 2.5 million years ago. In a sense, looking at distant objects is a form of time travel. We're observing the past, preserved in light traveling across the universe. Some experiments suggest particles might be able to travel backward in time. In quantum mechanics, antiparticles can be thought of as particles moving backward through time. This is called the Feynman-Stuke-Elberg interpretation. It's a mathematical trick, but it works perfectly in calculations. There are also experiments with quantum entanglement that seem to show information traveling backward in time. But these are controversial and not fully understood. So is time travel possible? The answer is yes and no. Traveling to the future is absolutely possible. We know how to do it. If we could build a spaceship that travels near the speed of light, or if we could orbit a black hole, we could jump centuries into the future. But traveling to the past is much more uncertain. The laws of physics don't explicitly forbid it, but every method we've imagined has serious problems. Maybe future discoveries will reveal a way to travel backward in time. Or maybe the universe simply doesn't allow it. One thing is certain. Time is far stranger than we ever imagined. It's not the steady, unchanging river we experience in daily life. Time can be stretched, compressed, and warped. It's woven into the fabric of spacetime itself, inseparable from space and gravity. Understanding time is one of the greatest challenges in physics. And if we ever crack the secret of time travel, it will change everything. So what do you think? Would you want to travel through time? Would you go to the past or the future? And if you could meet anyone in history, who would it be? Drop your answers in the comments below. If you enjoyed this mind-bending journey through time, smash that like button. It really helps the channel grow. And if you want to explore more cosmic mysteries like black holes, dark matter, and the Fermi paradox, make sure to subscribe to Cosmic Mysteries. Hit that subscribe button and turn on the notification bell so you never miss a video. We post new mind-bending space content every single week. Thanks for watching Cosmic Mysteries, and remember, time is an illusion. Or is it? See you in the next video.